Draw a ray diagram to show the image formation of a distinct object by a refracting telescope. Write the expression for its angular magnification in terms of the focal length of the lenses used. State the important consideration required to achieve large resolution and their consequent limitations. Okay. So to draw the ray diagram, we require two lenses here. One is objective lens and another one is the eyepiece. Okay. So here the first one is, this is the objective lens. This is the objective lens. And the second one, the small one, is the eyepiece lens. Okay. And all these two lenses are in a coaxial. That means on the same axis, these two lenses are placed. When the focus length is, when the light beam is passed in this direction over the objective lens, and it is reflected in this direction in this point, and again it is reflects like this, okay, and this is also the reflection, okay, and from the objective lens center, one more light is passed in this direction, and this will pass in this way and it will move in this direction, okay, and where these 2 points are coincide, the first lens and the second one, so the distance between from here to the coaxial axis, this is what we call as A dash and B dash. And the distance from here to the eyepiece lens, we call it as a eyepiece, okay, focal length of eyepiece, and from here to the objective is what we call as focal length of the objective lens. Okay, in this way it will be works. Now we need to find the angular magnification. For that, we are supposed to know the final image. The final image is formed at infinity when the image A dash B dash is formed by the objective lens at the focus of the eyepiece. That is, M is equal to tan beta by tan alpha. Tan beta by tan alpha, which is nothing but M is equal to beta by alpha. And M is equal to, we can write this one as H divided by F naught into F naught divided by H. This is Fe. H will get cancelled. Then we can write this one as F naught divided by Fe. Okay, this is the angular magnification. And the important considerations are, for achieving large resolution, the objective of the large aperture is required. And their consequent limitations are heavy, hence difficult to make and support by their edge, suffers with chromatic aberrations. Plot a graph for angle of deviation as a function of angle of incidence for a triangular prism. Derive the relation for the refractive index of the prism in terms of angle of minimum deviation and angle of prism. We'll see the prism image first. So this is the prism image. For this one, we need to plot the graph of angle of deviation as a function of angle of incidence for this one. Okay, this is the graph. This is the y-axis. The y-axis, we can see the angle of deviation in terms of delta. The value is 30 degree, 40 degree, 50 degree and 60 degree. And the x-axis, we can see the angle of incidence, that is I value. Okay, and here the curve will be plot like this. This is the curve, where here at this point this is the I value, and this is at 40 degree. I can call it as this is a I1, and this is I call it as a I2, where I1 is the angle of incidence and I2 is the angle of emergence. And if I want to take this one for the y-axis, this is the delta, and these both I1 and I2 it will be, and this is the delta value for angle of deviation for incidence and emergence. Okay. Now at minimum deviation, we have delta is equal to delta minimum, where I is equal to E, and R1 is equal to R2 is equal to R. Therefore, we can say R is equal to A by 2, because A is equal to R1 and R2, then 2 times of, since all are equal here, then 2 times of R is equal to A by 2. Okay. Then from the figure we can say that delta is equal to I plus I minus R1 plus E minus R2. Then delta minimum is equal to I plus E plus of R1 plus R2. Then I is equal to A plus delta minimum divided by 2. Then N is equal to, we can know that from the figure, since N21 that is equal to sine I divided by sine R. Therefore, N21 is equal to sine I divided by sine R. Then if I'm going to substitute the values, this becomes sine I is equal to A plus delta minimum divided by 2 divided by R is equal to A by 2, that is sine A by 2. This is the relation for the refractive index of the prism in terms of angle of minimum deviation and angle of prism.